Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to find derivatives of parametric functions. Now, first we must know what are parametric functions. Parametric function is a function in which both the dependent and independent variables are expressed in terms of a third variable. Thus, in parametric function, the dependent and independent variable are not directly connected. They are connected through a third variable, which is called a parameter. In this case, x is equal to f of t and y is equal to g of t. The two variables x and y are connected by the variable t. Here, t is the parameter. Okay, now to differentiate a parametric function, x is equal to f of t and y is equal to g of t, we differentiate x with respect to t to get dx by dt, that is equal to f dash of t. Also, we differentiate y with respect to t to get dy by dt, that is equal to g dash of t. Then dy by dx is equal to dy by dt divided by dx by dt, that is equal to g dash of t divided by f dash of t. Now in this way we can find dy by dx. Now let us take a question from your textbook from exercise 5.6. Now if x and y are connected parametrically by the equations, without eliminating the parameter, find dy by dx, where x is equal to 2at square and y is equal to 8t raised to power 4. Here parameter is t. Now for that we have to find dy by dt and dx by dt to get dy by dx. Now we first calculate dy by dt. Since y is equal to at raised to power 4 and a is constant, therefore differentiation of t is 4t raised to power 4 minus 1. So thus dy by dt is equal to 4at raised to power 3. Now we calculate dx by dt. X is equal to 2at square and 2a is constant. Differentiation of t square is 2t. So thus dx by dt is equal to 4at. Okay. Now dy by dx is equal to dy by dt divided by dx by dt. Now substitute dy by dt and dx by dt. We get dy by dx is equal to 4at cube divided by 4at, and that implies dy by dx is equal to t square. This completes the question. Now let's take one more question. We have to find dy by dx. Here x is equal to a cos theta and y is equal to b cos theta. In this case, the parameter is theta. Now to find dy by dx, we have to find dy by d theta and dx by d theta. Now let us first calculate dy by d theta. Y is equal to b cos theta. B is constant and differentiation of cos theta is minus sine theta. Thus dy by d theta is minus b sine theta. Also, calculating dx by d theta, x is equal to a cos theta. A is constant and differentiation of cos theta is minus sine theta. So therefore dx by d theta is equal to minus a sine theta. Therefore dy by dx is equal to dy by d theta divided by dx by d theta. Substituting for these, we get dy by dx is equal to minus b sine theta divided by minus a sine theta, and that is equal to b by a. This completes the question. Now let's take one more question. This is a bit lengthy as compared to question first and question second. Here x is equal to sine cube t divided by under root of cos of 2t, and y is equal to cos cube t divided by under root of cos of 2t, and t is the parameter. Now we differentiate x and y using quotient rule. In quotient rule, we differentiate numerator and keep denominator as it is, minus differentiate denominator and keep numerator as it is, divided by denominator square. Now, applying the quotient rule to y, we get dy by dt is equal to differentiation of numerator and keep denominator as it is minus differentiation of denominator keep numerator as it is divided by denominator square. Now here we have to find derivative of cos cube t and under root of cos 2t. Differentiation of cos cube t is 3 times cos square t, then differentiation of cos t is minus sin t. Also, differentiation of under root of cos 2t is 1 by 2 root of cos 2t, then differentiation of cos 2t is minus sin 2t. Then again differentiation of 2t is 2, that gives you minus 2 sine of 2t. There is no change in under root of cos 2t in first term of numerator and cos cube t in second term of numerator, and also there is no change in the denominator. Thus we get dy by dt is equal to minus 3 cos square t sin t under root of cos 2t plus 1 by root of cos 2t sin 2t cos cube t divided by under root of cos 2t whole square. Now cross multiplying in the numerator, we get minus 3 times cos square t sin t under root of cos 2t into under root of cos 2t plus sin of 2t into cos cube t divided by under root of cos 2t whole divided by under root of cos 2t whole square. Now here under root of cos 2t into under root of cos 2t gives you cos of 2t. So thus dy by dt is equal to minus 3 times cos square t sin t into cos of 2t plus sin of 2t into cos cube t divided by under root of cos 2t whole square into under root of cos 2t. Now in the denominator we have under root of cos 2t whole square into under root of cos 2t, that is equal to under root of cos 2t whole cube. Now replace the square root sign by 1 by 2. We get in the denominator cos 2t raised power 3 by 2. There is no change in the numerator. Thus we have completed differentiation of y with respect to t. Now we will differentiate x with respect to t, that is to find dx by dt. Here we use again the quotient rule. That is, we have to differentiate the numerator, keep denominator as it is, minus differentiate denominator, keep numerator as it is, divide by denominator square. Now here we have to find derivative of sin cube t and under root of cos of 2t. Differentiation of sin cube t is 3 times sin square t, then differentiation of sin t is cos t, and differentiation of under root of cos 2t is 1 by 2 under root of cos 2t, then differentiation of cos 2t is minus sin 2t, and again differentiation of 2t is 2. Now cross multiplying in the numerator, we get 3 times sin square t cos t into under root of cos 2t into under root of cos 2t plus sin 2t into sin cube t divided by under root of cos 2t into cos 2t. Now that will give you dx by dt is equal to 3 times sin square t cos t into cos 2t plus sin 2t into sin cube t divided by cos 2t raised power 3 by 2. Thus we can write dy by dx is equal to dy by dt divided by dx by dt, that is equal to, in the numerator we have dy by dt, in the denominator we have dx by dt. Since denominator of dy by dt is cos 2t raised power 3 by 2. Also, denominator of dx by dt is cos 2t raised power 3 by 2. So their quotient is equal to 1. Thus, dy by dx is equal to minus 3 cos square t sin t cos of 2t plus cos cube t sin 2t divided by 3 times sin square t cos of 2t plus sin cube t into sin of 2t. Since we know that sin 2 alpha is equal to twice sin alpha cos alpha, so we can use this trigonometric identity in dy by dx. In the numerator, we have sin 2t in second term, and also in denominator we have sin 2t again in second term. So instead of sin 2t, we write twice sin t cos t. Thus we get dy by dx as minus 3 cos square t sin t cos 2t plus cos cube t twice sin t cos t divided by 3 times sin square t cos 2t plus sin cube t into twice sin t cos t. Now in numerator we take sin t cos t common. Also in denominator we take sin t cos t common. Now sin t cos t in numerator and sin t cos t in denominator is equal to 1. Thus we get dy by dx is equal to minus 3 times cos t cos of 2t plus twice cos cube t divided by 3 times sin t cos 2t plus twice sin cube t. Now in numerator we have cos 2t in first term. Also in denominator we have cos 2t in the first term. Since we know that, we can write cos of 2 alpha equal to cos square alpha minus sin square alpha, or twice cos square alpha minus 1, or 1 minus twice sin square alpha. Thus we can write cos of 2 alpha in terms of cosine and sine, or in terms of cosine only, or in terms of sine only. In the numerator, since only cos is involved, so we write cos of 2t in terms of cosine only. That is, cos of 2t is equal to twice cos square t minus 1. In the denominator, only sine is involved, so we write cos of 2t in terms of sine only. That is, cos of 2t is equal to 1 minus twice sine square t. Now on simplifying this, we get minus 6 times cos cube t plus 3 times cos t plus twice cos cube t divided by 3 times sin t minus 6 times sin square t plus 2 times sin cube t. Now in numerator, minus 6 cos cube t plus twice cos cube t is equal to minus 4 times cos cube t, and in denominator, minus 6 sin cube t plus twice sin cube t is minus 4 times sin cube t. Thus we get dy by dx equal to minus 4 times cos cube t plus 3 times cos t divided by 3 times sin t minus 4 times sin cube t. Take minus common in the numerator, we get dy by dx as this. Since we know that cos of 3x is equal to 4 times cos cube x minus 3 times cos of x, and sine of 3x is equal to 3 times sine of x minus 4 times sine cube of x. Now use these two trigonometric identities in dy by dx. We get minus cos 3t divided by sine 3t, and that is equal to minus cot 3t. So thus dy by dx is equal to minus cot 3t. Now this completes the differentiation of the given function. Thanks for watching this video. I will continue this topic in my next lecture. Till then, take care of yourself. Thank you.